email address. And then I believe at one point I asked what you're going to be using it for, just to prove that it's educational. And there you can just type it's for like first robotics. Anyway, so I guess how much experience has everyone had? Like, have they created files? Do we need like how to CAD basically?
I know like some of the people that I was talking to, Brian, and Vishagan, and some other people like just felt a little bit intimidated by the interface and like weren't sure how to get started and actually using stuff.
Okay, so they've like never made anything on it?
Yeah, I believe that's where we're at. We can continue.
Okay, so I guess I can just get started. I'll share my screen. So, okay, so when you first enter Onshape, I mean, this is just the home page. To create a document, you just go to over here, create, and then document. Let's call this. So in here, you have both the Part Studio, and then also this is where you make the assemblies. So basically Part Studio, that's where you design the individual parts and pieces, and then the assemblies where you put it all together. So I guess the basic idea of CAD, I think you guys have probably seen in the workshops, is and then extruding it into the 3D pieces. So every piece, sorry, so every piece starts with a 2D sketch, and they all have to start on a plane. So if you start by just clicking sketch, and I usually do top plane, but it doesn't really matter in the end. That's just going to end up with which way your piece is oriented. So if I select the top plane, then you can right click and do view normal too. On these planes, you draw shapes, basically. Here you have different rectangles, you have circles, arcs. So if we were to make a cube, you can start with a center point rectangle. You click where you want the center to be, and then you just drag it out and click again. And then to dimension it, there's a dimensioning tool, and you can just make each side a certain length. Oh, also make sure that your workspace, I can't remember exactly where it is. I think when you initially set up your account, make sure that you are in imperial units, not metric. So now that you have this cube, you basically have the 2D cross section of it, or the square. Now to make it a cube, you want to extrude it. So you click this button here, extrude. And now you see it basically makes that 3D. You can set how big you want it to be here. So yeah, that would be 3 inches. There's different directions also. So you can see there's blind, which means just from the base that the drawing was made, and then just like straight up from there. And then there's also, well, I guess others require more. I'll come back to that. There's also, you can change the direction if you want here. And then you can also make it symmetric, so it extrudes basically out both ways from the center. Anyway, so if we're just making a cube here, you can also rename your sketches and extrudes just to keep things organized. So yeah, that's the basics of CAD. You just make the drawing, and then you make it 3D. And now if we want to add more to this, we can make a little die here. We can now make those same drawings on the faces of this already existing part. So we can make another sketch, and now select the top of this. And if we do view normal to, we can make a circle in the center. And if we want to dimension it, we can make that like 1/2 inch. And now when we extrude it, so there's 2 different types of extrudes. You can either add, which will basically add material, or you can remove, which will create a hole. So we can make this 0.25 inches deep. I'm going to rename this. And yeah, now we have a hole. If you're struggling to get the hole or the new part to actually be a part of what you've already created, the merge scope here, that's basically tells you which part it's going to be connected to, per se. So which part you're either taking away from or adding onto. So yeah, that's kind of the basics of it. There's also, sorry, I'm kind of throwing a lot at you guys at once. We're gonna have obviously a more in-depth curriculum later, but for now this is just how to make things. A lot of it is just trial and error and figuring it out on yourself or by yourself. One thing actually Onshape has is in this corner they have the learning center. That loads. Yeah, so it's basically this free training that they have. I mean, the videos kind of sound like they were being read by Siri, but they do have good, just basic courses that take you through the fundamentals, basically. I can't remember which it was. Yeah, these ones are really good. The Introduction to Parametric Feature-Based CAD and the Introduction to Part Design. All of these ones are really good if you want to work on that. These are all free. Anyway, so back to this. There's also, the nice thing about Part Studios is that you can make multiple pieces that fit together. So if I want to make basically another part that would go with this in an assembly, I could, so I'll start a new sketch. I'm just going to use keyboard shortcuts. If you hover over the feature in the toolbar, it does give you the keyboard shortcut like this. A new sketch is Shift S. I highly recommend using keyboard shortcuts. It makes it a lot faster. Just as you're first starting to learn the program. I mean, you won't remember all of them at first, but just try to use them. And if you forget it, you can hover over and look at it, and eventually just becomes second nature and it's much faster. So I'm going to make another sketch on top of this now, and I'll make a sort of bracket. So if we want to make a bracket that was connected to this hole, So yeah, we have to start the sketch basically against it, and I will make a rectangle here. So I'll do that, and then that. So it'll be kind of like a little T-gusset. So the big thing with drawings is that there are geometric relations between the basic shapes. So you can see here there is coincident is a big one that we use. It's basically, as it says here, make two or more sketch entities able to share the same location on a sketch. So basically, it just makes things touch each other. So if I want to make these two rectangles join up, I just select both of them, and now they're right there. Another really good one to use, yeah, concentric. I can show that one to you in a little bit. Parallel obviously makes two lines parallel. Tangent, it will basically makes a line intersect at one point of a circle. Horizontal and vertical, generally to the planes, perpendicular, two lines perpendicular, equal is really good for dimensions. So if you want to make like a square over here, you can dimension one side of it to be 1 inch, and then instead of dimensioning this side separately, you can make the two sides equal, and now it's a square. Oops, okay. Midpoint is also very helpful. You don't really use the others as much. So another big thing with drawings is using construction geometry. So if we want to align this hole with the center of this gusset, I would draw a line, basically from here. I'll just do from here to here. And instead of making this a normal line, I'll select it and then make it construction. So now this is just like for reference, basically. And then I can make this point a midpoint of this line. Okay. So now this construction line is basically showing me where the center of this whole like rectangle is. Although I should show, sorry, 1 second. Let me do that again. I'll also make it a midpoint to that. Okay. And then if I make these perpendicular. Okay. So yeah, if I make this construction line a midpoint of both of these lines, and then I make it perpendicular to one of them, it basically aligns this whole bracket, so now it's like a nice T-shape. So I'm just going to throw some random dimensions onto this for now. Make that 1 inch, make that inches, and I'll just set those equal to each other, so that equal. Okay. If you accidentally add a feature or a relation, like you can see at some point I accidentally made these two things tangent, that sometimes happens when you drag it, you can just hover over it and it will show the relations, and then you can just select that, and click delete, and now we can move it around again. So we have the basic shape of our bracket, or our gusset. So now I am going to make this circle on the bracket. On the gusset. There's two ways to do this. I'm going to make a circle, go into that midpoint line, and then draw a circle. So now I can select these two and make them equal, so we'll know that they'll be the same size. And then we can also select both of these and then make them concentric. When two circles are concentric, it means that they share the same midpoint. So that's a very useful feature. Now another thing we could have done instead of making a new circle is you can select this circle and then use the feature use, and that will now this circle, it is defined by the circle of the previous part. So for example, if I move this hole over here, let's say I just like throw it over here now. If we go back to this sketch, now it's also moved in this sketch because it's defined off of the circle that I made in the previous sketch. So that is a very nice feature for that's a very nice feature for like aligning holes on brackets and gussets, because if you in one of the sketches, then it will basically automatically update and you won't have alignment issues later on. Now if we wanted to add some more holes, we could either just make another circle manually, put on that construction line, set these ones equal to each other, and then dimension the distance between them. Make that like 0.75. Or we can use the linear pattern. So you start with one reference shape, and then you set how many basically of the pattern you want in each direction. This sets the spacing. What are these? And then you just get this nice linear pattern, which is a lot more efficient than doing it manually most of the time. Let's see, if it's, oops. So if your sketch is blue, or you're drawing, it means that something is not fully defined. Okay. So these here, because this was projected from a different sketch, it's fully defined because it is where the shape on other sketches, like that's where it is. But these are still free to move around, so therefore they're blue. So in that case, we would want to add some more geometric relations. So in this case, I will make this a midpoint of this. Oopsies, that was not right, actually. Oh, goodness. Not having that, okay. I think I accidentally added another relation. Ooh. Well, we could also just dimension that to be 1.5 inches from there. Sometimes the when it all turns red, it means that the sketch, like the geometry, doesn't work out if you try to add a relation. That can happen a lot if you've accidentally added a relation that you didn't mean to. Sometimes it's just kind of you got to go back and delete them and just guess and check and figure out what's causing that. It can be a bit of a pain sometimes. So I will add some more circles down here. I'll make another construction line. If you hover over, you can see it will automatically create a midpoint relation. If you just hover over about the center of the line, that's what that little icon there is. And then if I just drag over there, now we have another midpoint construction line, and I can make 2 more circles here that are both 1 inch away. And then make all of these circles equal to each other. Okay, so now we have the basic drawing shape of our bracket, or sorry, our gusset, that is based off of the geometry of this cube over here. So now we will, always get to name your sketches. Now we will extrude it. So in this case, we don't want to add, we want new. So this will create a new separate part. So instead of adding material straight to this cube, we're just creating another object entirely. So I will set the thickness of this bracket to be 1/8 of an inch, and there we go. So now we can see we made a bracket where this hole aligns with this hole. They're all the same size. So that will be very easy to assemble later. And here you can see your 2 different parts. So here we have the cube, which I should name, and here we have the bracket that we just made. Okay, so let's see, a few more features that are good to know. Fillets are a good one. So this fillet tool here, if you click on the corners, you can set the radius of the fillet that you want. And these are really important for when we machine things because the CNC can't do these sharp corners right here. Like that's impossible for the machine, so we need to round them out, and we can just use Onshape to automatically do it here for us. So yes, now we have nice filleted edges. Let's see, what else is there? I'm gonna show something else. I just can't remember what it was, my bad. There was also, okay, I can show the basics of an assembly. So here we have our part studio. So this is where we created our pieces. Now, if we want to put them together, we can go into the assembly here. So you no longer edit the way that the parts look at this point. This is just seeing how they all fit together, and you can add certain relations to restrict their movement. So I'm going to start by inserting the 2 pieces we have from this part studio. You can either insert from the document here, or you can go to other documents that are just in your Onshape files. So like, let's see, what do we have? Yeah, like here we have all of the just any other files you can take from any of the part studios that you made in other documents. But anyway, so if we want to go to current document, you can either select each item individually, or you can just select the whole part studio and it'll bring both pieces out, which is efficient. Then click the check mark. So now we have these 2 pieces that we brought in from our part studio. They're free to move around wherever they want. And this is where I should briefly tell you guys about degrees of freedom. So just if you just bring it apart, it will have 6 degrees of freedom, which means it can move sideways in both directions, translate, and then up and down. And then it can also rotate in all of those directions also. So when we add the geometric relation, or the mates in the assembly, we are basically restricting those degrees of motion to just what we want it to be, or degrees of freedom, sorry. So Onshape has a really nice assembly feature where it uses mate connectors, so it's really quick. It's like snapping together, basically. So there's different types of mates. There's fastened mate, which you really shouldn't use that much, except for the one time I use it is for mounting my first piece to the origin, because you can assemble all the pieces, but you need to mount one of them to the origin here, or the whole thing is going to be able to move around, and that's just kind of annoying. So you can see if you try to make a mate, and you hover over it, will come up with all of these points and vertices on the face of one of these parts. So I'm going to start by fixing this cube we made to the origin, just to kind of anchor it there. So I want to go down to the bottom of this, and when I hover over, I can click on that center point, and those little lines you see, those are the X, Y, and Z axes. So if I click that, now that point has one connector there, one mate connector, and now I want to put the other mate connector on the origin. So the whole point of these X, Y, and Z axes is that you can reorient them here. So I can flip the primary axis, which will basically just flip the whole thing upside down, or I can also rotate it, which you can't tell the difference with because this thing is symmetric. I'll show that again with this later. But so once you have that fastened now, you can just say commit current mate, click check mark, and now you can see this is totally fastened in place. It now has 0 degrees of freedom. And as I said, this is nice for anchoring, but the reason you don't want to use this with mate connections between other parts is because it will automatically just fasten them together, and you won't be able to tell if you have as many issues with alignment. So the one that I would highly recommend using otherwise would be the Revolute mate. So the Revolute mate, if you hover over all of these, it tells you about exactly which degrees of freedom it restricts the piece down to. So Revolute, it's basically, it will allow something to spin or revolve around something else, another point. So I usually use these for as an imaginary rivet per se. So if I click on this one, I want to attach this bracket now to this cube. So I will start by putting a Revolute mate. Also be careful, because you can see when you hover over things, I can either put a Revolute mate on this face down here, or on this upper face, and those will be 2 different things. If I made it to this bottom face, the whole bracket will be inside of the cube, basically, and we don't want that. So if you're struggling to like select this, what you can do is, since we want it to be on this top face, you hover over that, you hold down shift, and then you can basically be at that center point still on that plane. We want that. And now we will select, I believe it's this part. So I'll do the same thing, hold down shift on that face, and then select the center of that. So now these 2 holes will be aligned, and this is what I mean with the reorienting the secondary axis. It'll basically flip that around, which doesn't matter for the Revolute mate because it'll be able to rotate anyway, but for some of the other mates, it does actually make a difference. So click check mark, So now with the revolute mate, this part can now rotate around there, but it cannot move up and down. Another useful feature for assemblies is if you just select a part, it will come up with this little, I believe they call it a triad. So if you move this to where you want to basically rotate things from, I can stick that there. You can then use this to, if you want it to set it to a very specific angle, you can just type it in there. It's also, because now if we do that, you will be able to tell that this cannot actually move that way because the mates restricted that movement. So yes, now we have that. Normally to assemble more of these here, let me show you. If I add another hole to this cube, go. It's another circle, them equal, set the distance of 1 inch. And so this is another interesting thing, a really powerful part of CAD. So you can go back and edit features. And because everything is sort of based off of the other features that you previously created, like they'll all update to company for it per se. That's what it means by being parametric, is the features kind of they're based off of each other. So if I add this other hole, because it was part of the sketch of the first hole, if I just click the check mark, here I'll hide this to show you, it will already have extruded and fit a hole. That's another feature here. We have you can hide and show parts, just using that. You can also right click on things and then do hide. So yeah, now that we have the second hole, if we go back into the assembly, you can see it actually automatically updated to have that second hole now. So if we add another mate, since this is still free to rotate, which we don't want, so we can add another mate. I'll add another revolute mate from there, and then I'm going to hide the cube, or make transparent, sorry. Make this transparent, and then select that hole right there. So when you first add a mate, it's basically gonna ignore all the other mates you made just to get those two holes in, or those two mates aligned. So the way you see it with the other mates you previously added is you click this button solve, and now everything goes back into place. So now this can't move because it's both of these. It's allowed both. So the bracket is allowed to rotate around both of these points, but it can't technically do both. So now it's fixed in place. It's like adding 2 rivets. So the other mates that we have that we use, I really don't use really any others besides revolute, and then occasionally planar or cylindrical. I can demonstrate these better. So one thing you guys will also want, sorry, once again, this is a lot, but hopefully you can look back at this later and just work through this slowly. MKCad. So if you go to, here, so when you first go to Onshape, you're going to want to go to this app store. And in it, you can search up MKCad. And this was created by another FRC team. And it basically has all of our commercial off-the-shelf products, COTS. And you can just easily insert them and configure it. So I believe, since I already have mine downloaded, I think it's just like a little install button. It's totally free, and it just, and you can just add it to your Onshape interface. So you can see once you download that, when you're in your assemblies, there's 2 ways to access it. Either if you go to insert and then other documents, I believe that is it shared with me? By the way, you can search CAD stuff, and it will have all of their parts. That is technically one way to do it, not the best way. The other way to do it is here you'll have a little tab where it says MKCad Inserter, and it has an organized list of all of the parts. So this is where you will find like everything that we need. There is yeah, just like rivets, shafts, motors, yeah, bearings. So if I want to get a shaft, so let's say I want to put a shaft through a bearing. So I'll get this 1/2 inch hex shaft, and so I set the length. I'll just make it 2 inches. You can set here what type of shaft you want it to be. I will just make it a 1/2 inch hex. And then for retention, so we oftentimes there's different ways to retain shafts. We can use, as they have it here, the snap rings, where you just make the little, you lathe the little just inset the snap ring into. There's bolt and washer where you tap the end of the shaft, put a washer on there, stick a bolt through the end. That's the shaft collar. So here I'll just do a snap ring, I guess. And then on the other side, I'll just keep that. So here for the end, for the first snap ring, I'll say yes, include everything and merge, so it doesn't give me the separate parts. And then for the second one, I just don't want that second snap ring, so I'll say don't include. So now when I say insert, just takes a second to generate, and it always generates at the origin, so oftentimes it'll kind of get stuck in other parts. But now I have this shaft. So now I'm going to get the bearing for it, and the bearing will be here, and we'll want the 1/2 inch, here we go, not hex, I'm around, 1/2 inch round. Just select that. It's kind of stuck in there, but okay, so now we have our shaft and our bearing. So when it comes to making shafts and bearings, this bearing doesn't technically rotate, but you can use, once again, a revolute mate to allow the shaft to rotate within the bearing. So if I select revolute mate, I'm going to want one revolute mate to be right here, because that's where the shaft collar will be sitting right up against. And then for this other, I will basically highlight that face, or sorry, I will highlight right up against the shaft, or the C-clip. And then if I go to the center, I can select that point for the mate connector. And now these 2 faces will be right up against each other. Oopsies, I think I clicked the X, not bad. Do that again. So now this shaft is able to rotate within this bearing, which actually the whole thing rotates because the bearing isn't fixed. Okay, let me hide this, sorry. Just for demonstration purposes, I'm going to fix this bearing to the origin. And now you can see I can rotate the shaft within the bearing. And the bearing stays in place. So that's basically what you want to do. And then when you stack things on top of that shaft, like let's say I'll get a gear. You can get a, I don't know, just a half-inch, okay. 16-tooth, half-inch hex gear, okay. So now, nope, that was not the right type of gear, not bad. Okay, that's what I want. So I'll just insert this random gear. So when it comes to these mates, it's not really the most important thing for the gear to have to rotate with the shaft. So there are like ways you can make like the gear mated to the shaft centered, but that can get quite tedious. So a lot of times I'll just make a revolute mate to the bearing. So I'll just that and over to this bearing face. Oh yeah, and you can see here. So the two mate connectors are basically shoving this gear through the bearing. So in this case, I will want to flip the axis, and now it's facing the correct direction. By the way, please never put a gear directly up against a bearing. That is a terrible thing to do. This is just for demonstration purposes. But so now we have this, and the gear can rotate around the bearing, and it is centered on the shaft. So yeah, that's what we tend to do on the robot. By the way, when these things come in, those right there are mate connectors that they're just automatically showing when you import it from MKCad. If they annoy you, you can right-click and say hide all mate connectors, or you can be annoying and say show all mate connectors. Which where did that go? It was. Well, you can if you're having an issue with mates, you can do show mates. And that is showing that there's a revolute mate. So if you select it, it will highlight it over here. And here you can edit your mates. So if you decide that you don't want it to be a revolute mate, you can double click it. And here I can show you what a cylindrical mate is. So the cylindrical mate, I changed that mate type now. So this gear can rotate around that point, but it can also, I don't think I did that right. Change the right one. Okay, I changed the wrong one. That was for the shaft. So now the shaft has a cylindrical mate, so it can rotate around the bearing, but it can also move up and down through it. So I'm going to change that one back to being a revolute. Also, if you select if you hover over the mates over here, it will highlight which pieces that mate is for. So here we want to edit, once again, that revolute mate between the bearing and the gear. I can show you what the slider mate. So this one, now the gear is no longer able to turn, but it can slide up and down. This one, you can see here, these shafts aren't like, well, I guess it doesn't really matter. But so if that's not aligned properly with these sliders, you can use this reorient, and it will basically, you can see that hex in the center is like shifting around. So yeah, those are the basic mates. I mean, you can play around with those a little bit more, honestly. Oh, one more important thing. So if I want to do a revolute mate, but I don't want this to be flat against here, there is offset. So I can offset this to be 0.25 inches. It went the wrong way, so now I'll just click that negative. And now it has a 1/4 of an inch between that face, which can be very helpful. So yeah, I think that's kind of the basics with mates like that. Yeah, assemblies, you just kind of, you got to play around with them, get used to it. Let's see. Is there anything else?
Could I ask? I think that was a great overview. I liked what we went over.
Yeah, if there's anything else I need to add, just
mates
tell
and
me.
everything and drawings. I think right now we're coming up on the Crayola CAD process stage of our process. So could I ask some specific like drawing questions with that?
Yes, I can do a rudimentary drawing. Show you that.
Yeah, and I like the geometric constraints that we went over. I think that was really good. But I think could I ask like some questions on like just tips for Crayola CAD and other stuff like that?
Yeah, here I'll open a new. Also at the bottom here, if you want to make a new tab, new part studio, insert tab, create part studio. Okay, yeah. So what are your questions with the Crayola CAD?
Yeah, so I can. So questions that others might want to know. Did we do Crayola CAD this year? Is there any that we could look at?
Yeah, I mean, if you just mean rudimentary sketches, here, let me find it. I think it was under prototypes. We had a lot of drawings. Jack and I made quite a few just of like the whole robot concept. Like here, where was, I'm going to show the one that Jack made. This one's really good. It was, not that. This is what you're referring to, right? With Crayola CAD? Okay, so this is, yeah, just a 2D sketch. We have the speaker with the subwoofer here, and then over here we have the robot. So you can actually, a lot of times, like, I hope this one can pivot. Yeah, so you have this part. And if you define these shapes correctly using those geometric relations, oftentimes you can like pivot here. Wait, let me find the others. Sorry, there was another. The arm. Gotta find it. Sorry. Yeah, so this was like kind of our refined Crayola CAD. So you can see we have this. So you can actually take this, highlight it, and then if you select right there, or sorry, if you use where is it? Under here, transform. it gives you that little movement triad. Oopsies, that's not what I wanted to do. If you grab from the origin and place it around your pivot point, then you can basically rotate your sketches to see how the geometry of things will work out. So this is very good for like if you want to test for clearance of things. Like this is how we tested to see if the shooter would stay within the like this line here. That's the extension limit. So we were testing to see if our robot would actually like be legal. And then later we also did that same process to see if the like feeder into the amp. We have like a little note here, and we wanted to see if that would like just pathing it basically, 2D pathing and using geometric relations in the move the point of triad to your pivot point, then you can move things around and just see how your systems will interact with each other, and it is so helpful to do. Sorry, what were your other questions? I don't know if that was really what you were asking for.
So how do you recommend, like, how did you guys go from like a blank document? How did you guys start getting stuff down and getting ideas down?
Yeah, that's a hard one. So it all started with whiteboard sketches. You draw stuff on paper and you just get your like basic concept. So once you have that, you then go into creating just a very rudimentary 2D, like I don't know if we have any of the more rudimentary like sketches, but it's basically doing what I did, but with like a very simple kind of where'd it go? Don't remember where all this went. Do I have it in these? You slowly just start to basically draw out the path of where you want the scoring pieces to be and where you want those mechanisms to be, and slowly you just add more and more detail to that 2D drawing. You just figure out like where things will physically fit. I mean, you block out like where the like drivetrain is, and slowly, I mean, you can see this was like an old arm. It was just like pivot points, and then eventually you start to kind of just build on that, and you find where exactly the note will be, what dimensions it needs to be, like where the gear or where the motors and the gearboxes will all sit, and then once you have that, you can start to just create the preliminary part studio, where from that basic geometry that you just kind of slowly added onto, you can just create like a very basic mechanism, and then that mechanism will just naturally evolve as you start putting everything together. Sorry, I know it's kind of an intimidating process, and it seems like how are you supposed to do this, but it's just kind of slowly adding things on to 2D drawings until you have enough to start basic 3D.
Gotcha, that makes sense. I think this was a good overview. Is there any other questions that might be helpful asking for other people?
Yeah, if anyone has anything, just like you can also DM me later. See, I know that was kind of a lot, but there's a lot to learn. We'll have a more comprehensive curriculum later. Once again, the Learning Center in Onshape, that's a nice place to start if you just feel like a little lost. But yeah, when it comes to robot design, that one doesn't help that much.
I'm only gonna pretend like my head isn't spinning right now.
Yeah, I'm sorry.
No, you're good, thank you. But is it possible if we could like say go over, I don't know, say preliminary Crayola CAD for Baby Weiwei and kind of get some ideas for that? Because I know we're kind of a little, I don't know, trying to move into that stage as one you were saying. Maybe some help with that would be cool. It's like one, like just wondering where are you currently at with the Crayola CAD?
Yeah, I honestly have no idea either, so that's a good question.
Yeah, we're still very much getting started. Yeah, like I mentioned the other day, yeah, we're getting started with finals and everything. But we have the field element sketches, and I know people, like I was talking to some people and they were feeling a little intimidated with like navigating Onshape, and like how to get actual stuff drawn out. So I think this is a good overview in terms of, and I like how you went over all the constraints and like geometric stuff like that.
Yeah, those are your best friend.
I think that'll be good for people to be slightly less intimidated by it, but we're still getting started. Yeah, hoping to get a lot done over these next coming days.
Okay. Yeah, I mean, if you guys get stuck again, just like reach out. I mean, I'm going to be a little busy in the next few days. Next week I'm getting my wisdom teeth out, so it's possible I'll just be drugged out of my mind and telling you gibberish, but I can try if you guys need it.
Thank you for the dedication. Good luck with the wisdom teeth.
It'd be great.
Ash, do you think there's anything else that's like helpful to cover? Any starting tips for people as they get started?
I mean, I feel like Elie did a pretty good job. I think patterning and mirroring is like good to cover as well. Like patterning and mirroring.
Yeah. Oh, mirroring. I forgot about mirroring.
Because I know you did patterning. But there's also like part patterning and then sketch and part mirroring.
Yeah. Should I go over that real quick?
If you want to, I think it's not. I don't think it's super necessary. I think like the main tools that people use is like the line tool, the rectangle tool, the circle tool, maybe the arc tool. It's all stuff you've already covered is like what people generally use. Maybe showing them how to make a new plane would be good.
Oh yeah, that's a good point. Here, let me do that really quick.
Yeah, and then I think that'd be a good ending point. I think we've covered a lot.
Okay, and you did record it, right?
Yep, it's recording.
Okay, good. That's good.
Yep.
Where did that go? Okay, here we are. So, new plane. Let's see if I remember how to do this. So you select plane, and then basically there's like different weight or different types of planes. You can like Google them if you need to. Some of them are. I was using tangent. That one's difficult. It's for cylindrical faces. Don't recommend that. It's kind of horrible, but sometimes necessary. Mid plane. That one's probably good. Or we'll just do offset. So I believe you select the face that you want the plane to be on, and then you can offset that plane. Yeah, we can just say like 1.5 inches. So now we have this new plane that we can make sketches on. If we make a new sketch, we can select that plane, and now it's a new plane that isn't any of the just 3 basic top, front, right, and it's not one of the parts that we got recreated. That's kind of it. I don't know. It's, yeah.
Great. I think that's awesome. I think we've covered a lot of good stuff.
Yeah, obviously everyone can go back and review this because I know that was a lot at once, but it's just a lot of figuring it out yourself, and a lot of times you just kind of have to Google, like, what is this feature in Onshape?
Yeah, I know I did a lot of that too. Yeah, but exciting stuff. So I'm sure everyone.
Yeah, it is. Sorry, keep going.
No, I remember getting started. It's a little intimidating, but I think this is a good start.
Yep.
So thank you, Elie. I think this was great.
Yeah, glad I could help. Once again, if you guys need anything else, just reach out. That's what I'm here for.
Yeah, big thank you.
Yeah.
Thank you.
Hey, Juan, do you want to possibly go over design ideas for, I guess, Baby Weiwei Jr., kind of the design idea that thinking of so we can move towards the Crayola CAD, or?
Yeah, gotcha. So that's one of the things I'm curious about, actually. So once we have our design idea of using an arm, how do we actually, so there's different forms that an arm can take shape. So is that something that each person does individually, or would it be good to decide on that now? What's a good way to handle that? Like, how does that take form?
So I was kind of assuming that everyone would attempt to try like their own version of Crayola CAD, and then we move forward with whatever one, is the most developed. Because I think everyone should get, experience in each step of the process. I know nobody's really been chatting about it, so it might take a little bit longer just because of lack of communication.
Yeah, that might be something on my part-ish.
I don't think it's on anyone's part. I think it's like finals have been going on, and like school just ended.
So real time.
I know we have like a chat but it's not accessible to everyone. So it'd be good to have that in the server. That's actually a great point, and probably wise to do that. So yeah, we'll move everything over to the server. There hasn't been a whole lot going on with finals, but yeah, I'm realizing that's probably not the best. But we had a thing going with like everyone who was interested. But we'll move that over to the server. Could we make a channel for Baby Weiwei if possible? Is that a thing?
Absolutely, I'm doing that right now.
Perfect. Because I know that's one of the things that like sucks is not knowing what's going on. So yeah, thank you for pointing that out. But yeah, I'm hoping to see people get started, and I think this meeting was a good starting place.
Yeah, I mean, do we want to have like a small Baby Weiwei meeting now, just to see where everyone's at?
I think that'd be good.
I kind of need to go, but like, you guys can probably handle that yourselves.
Thank you so much, Elie.
Yeah, my pleasure.
Okay, thank you.
Bye.
Thanks, Elie.
What did you want to go over, Ash?
I mean, okay, so like I said, I kind of want to see where everyone's at. I know it's now just you and Ben in this channel, and that's all right. I haven't looked at anything anyone's done so far, so.
Yeah, and yeah, I'll be honest, we're still very much getting started.
Yeah, and that's fine. And I'm gonna try to give you guys a little push.
Okay, I like that encouragement. I think that's great.
Well, I mean, I did a quick 2D sketch of like what your 2D sketch should probably look something like, but I want to see what you guys have first.
Okay. Because I know you showed me the bare metal amp score and kind of the climb, so I kind of have the idea of what I'm kind of looking at, or at least what we may move forward towards. And yeah, it's just mainly been time. Like today's the first day I've been able to sit down and actually work on stuff, which is really nice. So
yeah, right now, if you're like wondering where we're at, we kind of just have field elements done. That's kind of it at the moment. Hoping to get a lot more done. I haven't had a whole lot of time recently, if I'm being completely honest, but hoping to get started. And everyone's in the folder in the team.
Cool.
So because I know like actually, some people that we were talking to didn't even know how to like rotate the camera and things and certain things like that. I think the geometric constraints are a good start. And I think if we give them a push, I think people will get started.
Yeah, I'm gonna have time today till Monday, and then after Monday I'm gonna be out of the country for 9 days. So I'll try and get at least, because I know Ash, you said we should each do our individual. I can try and get mine done. Well, the goal is to get it done by Monday anyway. So that's what I'll work on.
Could we have a follow-up meeting at some time during the weekend and like expect people to show up with stuff done by then? And then if we call them out on that, I think that'd be great.
Have it be a Sunday thing? I'll put out an announcement in the Baby Weiwei channel.
Yes, I think that'd be
okay. And then I think at that meeting, if like there is a good well, okay, so I think once you have a 3D Crayola CAD, that would be a good time to start assigning people to different areas of the robot.
Gotcha. Is the deadline for that also Monday?
No.
Okay, it's a little after that. Okay, if you could have a follow-up meeting on Saturday or Sunday, I think that'd be great.
Cool.
And then we encourage people to watch the video, and if they have spare time, a little movie night. Yeah, for sure. I think we're on a good place though. I'm looking forward to it.
So you just have field elements?
Yeah, nothing's totally been done yet. That's all I had time for. So I'm
going to share my screen. That's the wrong screen. That's really cool.
Question: should I keep recording?
Oh boy.
Should we keep this as part of the record? Is there stuff you want to show that'd be good for other people to see as also?
Sure.
Okay.
All right. So just gonna walk you through my process a little bit. Start with the known things. Okay. So you know that there's going to be a floor. That's usually the first thing I put into my sketches. And then the drivetrain you have is already, a real thing. So there's not a lot of thought that needs to go into that. So you got, 2 wheels, a 2-inch bar in the middle that is roughly at the height of where the current drivetrain is, I think. And then you have your bumpers on each side. So, and those are just 3x5 rectangles. One is very clearly higher off the ground than the other, and that's just because we decided to do an under the bumper intake. So I believe, so this is 2 inches off the ground. I think that the highest that your bumpers can go is actually 7.5 and not 7. So this line is at 7. So you might want to raise this bumper height a little bit, but it's not super integral to the rest of the design. So after I had my drivetrain in, I put the amp in. So that's these lines in here. And then after you have your amp and your drivetrain, I stole some measurements from Orbit. I don't remember if I shared a window or just I don't know what my stream looks like. Can you guys see Orbit's?
Yeah.
Yes.
Okay, cool. So they have their Onshape link. Hopefully it doesn't take 5 years to load. It might. It's a pretty in-depth robot. So we'll just let that cook for now. But I stole some measurements for where their rollers are. And then I knew we wanted this arm structure. So I put this note here to show like where we want the note to end up. And some rollers here. And I know we need a tube. Yeah, you know what I say. You guys know what I mean when I say tube, right?
Aluminum tube.
Yeah, like a rectangular tube.
Yes.
Okay. Just checking. And then in this sketch, I was able to rotate this part. It's now constrained. But something I like to do, so Elie showed you how to move stuff with the triad. I usually just do the circular pattern and kind of put it in an end position I like. So after I had those, then the next issue is getting this note up to there. And I want it to be relatively perpendicular in that transfer. So that's why this line exists. These move, but I think like for any sort of transfer, you just want to make sure that the note is hitting, well, that these are where the note would hit this wheel first. So anywhere in like this range is probably fine. Come back.
How did you get the down position of the arm?
The down this position?
Yeah, because it's defined. I'm just curious, like, how'd you get that there?
So it's just this position rotated 125 degrees.
Okay. Is that based on anything, or?
It's just where I liked for node transfer.
Gotcha. Okay.
And this only took me, I don't know, like half an hour-ish. So they hopefully, it's, okay, I've been doing CAD for a while, so it's probably quicker for me than most, at least on the team.
Yeah,
I wouldn't say expect half an hour, but they shouldn't take, like, it's not super high level of detail. Like, this is just kind of what you want your robot to do.
Mm-hmm. Yeah.
I see the vision.
I also see the vision.
Yeah, and I think that's also what's important, is that, like, other people, if you talk other people through your sketch, they can see what's happening. You don't have to make sure that they know what's happening, like, first glance. Because if I looked at this first glance, I'd be like, what the heck is this? This is a giraffe, actually.
But okay, that gives good guidance.
And then I think what's nice is the stage is like right here. So you're still under the stage when that arm is stowed. So that's probably also a construction line you would want to have in there.
Mm-hmm.
Yeah, and then as well as trap as well, right?
So I would recommend making that a different sketch.
Okay.
So I think doing the amp sketch first is good. And then moving, like, I would take, most of this. So like this and your drivetrain, I think you want in that second sketch.
Okay.
For your trap storing.
Sounds good.
Thank you, Ash.
Yeah, thank you very much.
We'll get to right on that. Get to work.
Okay. All right, I gotta hop off though. So
I do.
thank you guys.
Bye, man.
See ya. Have a good one.
Good luck.
I think we're good here as well, Ash.
All right, cool.
Perfect. Thank you. I'll end the recording.
All right.
Recording has been